look at 8F, which is rules for the nth term in a sequence modeling geometric growth and decay. Now, recall from the last video on 8E, if we've got geometric growth, we're talking about compound interest, and decay then was that reducing balance depreciation, okay? Creating that rule for the nth term means we can substitute in n, so any value of the term. If I want to know the 112th iteration of the rule, I can substitute in 112 rather than calculating it 112 times. So previously, if we're looking at compound interest, we had this rule where VO is the principal and then Vn plus 1 equals R times Vn, and R was us working out that rate that we were multiplying by. This time though, we've got our rule as Vn equals R to the power of n times that VO, which is our principal amount. Now, R to the power of n, you might be thinking, where does that come from? Well, remember previously we would do R times Vn and then we would calculate it again. So we'd multiply it by R a second time and then a third time and then a fourth time. If we keep multiplying something by the same amount, let's just say we've got x and we go times x times x times x. Remember, we can actually substitute that with an index law as being x to the power of 4. So when we just did it one time x times x, that was x squared. So what that means is we've done it x times x, we've had two x's there and we've used x squared. So that's why our rule has R to the power of n times VO. And remember, R is still calculated here from taking 1 plus R over 100 because we're adding on that interest rate per compound period. So if we look down at question 1 here, we've got a principal value of $14,000 is invested in an account earning compound interest at a rate of 6% per annum. The rule for the value of the investment after n years is shown below. So we've got this rule here. It's put 14,000, that was our VO, so that's sitting over here for us, and it was 6% per annum. So we've got here 1.06 to the power of n, because remember 6% per annum means 6 over 100, and we're adding that to 1, so that's like saying 1 plus 0.06, which is why we get 1.06. Now find the value of the investment after 3 years, means I want to find V3. So I want to find 1.06 to the power of 3 times $14,000. So again, if I head back to my calculator here, I can put 1.06 to the power of 3 and then multiply that by 14,000, and I get here 16,674.22. Sorry, 16,674.22. Remember, $, 2 decimal places every time. Now, part B wants us to find the amount of interest that was earned after 3 years. So remember, this is that final value. The interest is the difference between the amount that I end up with and that $14,000 that I started with. So in this case, the interest that was earned was 2674.22. So in 3 years, this person's earned $2,674. It's pretty nice money for just having money in an account there. Now, part C, it says if the interest compounds monthly instead of annually, write down a rule for the value of the investment after n months. Remember, if we're working at compounding monthly now, I need to take that interest rate and I need to divide it by 12 because there's 12 months in a year and this was a yearly rate. So 6 divided by 12 here actually becomes 0.5% per month. And so now if I rewrite this rule, Vn equals 1.005 to the power of n times 14,000. Remember that 0.5, if I now want to make that divided by 100, I need to still move that decimal point 2 spots there. That's why it becomes 1.005 to the power of n. Now this rule will now work for me to calculate it with n being months. So part D, it says use the rule to determine the value of the investment after 3 years. Remember, 3 years is 36 months, and it's calculating that compound then 36 times. So now I'm going to have here 1.005 to the power of 36 times $14,000. And let's now pop this in here, 1.005 to the power of 36 times 14,000, and I get 16753.53. So we can see there from compounding monthly instead of compounding yearly, I've earned about $80 more in interest, which, I mean, it's not a lot of money, but that's money just for having it compound monthly instead. So if that was you in your bank account, you'd want compounding monthly because you're earning little increments more over time. Now, part 2 here, question 2, this is asking us how many years will it take an investment of $2,000 paying compound interest at 6% per annum to grow above $3,000 here. So what we need to do then is, first of all, create a rule that we're working with. And I know here that VO is going to be $2,000, okay? And that compound interest is 6%, so R equals 6. So if I write a rule for this now, Vn equals 1.06 to the power of n times $2,000. That's the rule that I'm working with. Now this question wants to know how long will it take it to be above 3,000. So what I'm saying is 3,000 is the value here. What's n going to be? Now we can actually use that solve function in our calculator again. So we're going to go to solve here. We're going to put $3,000 equals 1.06 to the power of x, okay, times 2,000. And remember, I want to solve for x, so I always need to press comma x and then close that bracket. And what I get here is 6.9585, blah, 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 blah. It says grow above 3,000, and I always need to give my answers as whole numbers, which means in this case I always need to round up, because if I say only 6 years, I'm sitting under $3,000. So my answer here is that it's going to take 7 years for that investment to be larger than $3,000, so 7 years. Now, if I scroll on down and do this in terms of reducing balance depreciation, recall from last time, I still had that same rule as compound interest, but the R came from subtracting the rate away. And so I actually still have the exact same rule for depreciation as well, where it's R to the power of n times VO. But remember, in this case, my R value is going to be between 0 and 1 because I'm subtracting a rate away. So if we come down here, it says here that a computer costs $9,000 to buy, so that is my BO, and it decreases in value with reducing balance depreciation of 20% per year. Write down a rule for the computer after n years. So in this case, my Bn equals, now R, remember, is, let's just put this in brackets, 1 minus 20 over 100 times VO, which is 9,500. So I can simplify that 1 minus 20 over 100 to be 0.8. Oh, sorry. And that's to the power of n. So 0.8 to the power of n times 9,500. That's the rule that I'm working with. It says here, use the rule to find the value of the computer system after 8 years. So it says now if n is 8, so I'm doing 0.8 to the power of 8 times $9,500. So if I pop that in here, and I get here 1593.8 0.84 to those 2 decimal places. So I can see now that in 8 years, the value of the computer has shrunk by about $8,000. And it says calculate the total depreciation. So that wants to know then, well, how much money has been lost? What's the difference? So I need to do 9,500, that initial amount, minus how much it's worth at the end of the 8 years. So 9,500 minus 1593.84. And I get 7906.16. So yeah, it's lost $7,906.16 in that 8-year time period. I have one more question for us to do. It says that a harvesting machine was purchased brand new for $65,000, and after 12 years of use, its estimated value of $22,000. If the value of the machine is depreciating using a reducing balance method, what is the annual rate of depreciation? So this time it works to work out the rate that it's losing value at. So VO, that's my initial amount here, and my final amount I've got there is $22,000. So first of all, I need to work out, well, how much has it depreciated by? What was the total value of depreciation? So 65,000 minus 22,000. Which is $43,000 that it has depreciated by. And now I need to think about this in terms of my rule. So I'm saying $43,000 equals 1 minus R over 100, because I don't know what that rate is, to the power of 12, because it's been 12 years, times 65,000. And what I can do now here is I can, again, use that solve function in my calculator because I don't know what that variable is. So 43,000 equals, I can set up that bracket and put 1 minus, and then in here, got to use these variables that are on here. So x over 100, close that bracket and do that to the power of 12, and then multiply that by 65,000. Press comma x and now close that final bracket. This is going to give me a few values here, and so I want to pick that first value that we've got there, so that 3.38%. It said write an answer to 1 decimal place, so that's going to become 3.4% as the rate of depreciation there. So that's saying that each year the harvesting machine is losing 3.4% of its value, and then that's calculated again the next year, etc., etc. So hopefully that gives you an idea of how you can create the nth rule for geometric growth and decay, and then how you can also use those rules and use the solve function on your calculator to find some answers when you perhaps don't know what the rate was. And yeah, you can work out how much something is decreasing or increasing by. Thanks.